In this video, I'll show you the projections of inclined lines. That means when the inclined line is just given on the space, then how we could just produce projection view. That means on front view, side view, and then the top views of that line. Before projecting these views, what is really an inclined line means? An inclined line is a line which is parallel to either of the three planes here and neither parallel nor perpendicular to the other two views. In this case, if you see line AB, it is parallel to the horizontal plane, but it is not parallel or perpendicular to the other two planes, which means with the vertical and the profile plane. To clearly understand the positions of this inclined plane on the 3D surface, let me show you with this animation. If you look over here, the line is just placed in this way. That means it has the same distance from the horizontal plane. That means the y components will be the same from the horizontal plane. That means point A and point B are placed in equal lengths. Whereas when you just look this line from the perspectives of the front view, B is near to the vertical plane, but A is far from that plane. And then in the other one, when you look just from the side view, A is near into the profile plane, and then B is far from that plane. But on the horizontal plane, they will have the same distance. So such types of lines are called an inclined line. So the projections of this line on different view can be projected here. So once you just understand the exact positions of the line on the space, so how we can convert that into the projection view can be expressed in this way. If you want to know more about normal and then oblique line projection, you might just refer the link attached on the video description, and then you can even understand how we can project a normal and oblique lines here. So in this video, we'll focus on the inclined line projection. So if you just project this, that means if you project into the front view, if you just rotate into this part, let me show you with the animation. If you just rotate into this part, you'll get a line on the front view. So but that line is, as you see here, it is diminished or having a shorter length than the actual length. So it will be projected in this way. Once you project that, both points, the endpoints of the line will be projected, and then there will be A and B for the front view. That means AF and BF will be this one. If you connect them, you'll get that line. So that line is the projections of the exact line or the multi-view drawings of that line on the front side, or it will be on the vertical plane, can be projected in this way. And then the other one, we can just project it on our plane here. That means from here to here. If you just measure the dimension, that means point A from into the x-axis and then point B into the x-axis, and then if you just align that, they will intersect at this point, and then you will get that line. That means the horizontal line will be AF, BF. So this is the projections of the line on the front view. And then the other one, when you look into the profile plane, the side view can be constructed in this way. So from here to here, I will have AR and then BR here. So once you get that, you can construct that projection, and then the same thing on the 2D plane or on the multi-view drawing, we can construct that line, and then it will have such types of lengths. So the side view will be also shorter than the actual lengths of the line AB. And then this is just the right side view. So AR, BR will be the right sides of the given line AB. On the other hand, on the top view, if you project over that, you'll get both point A and point B in this way, and then you can construct that line, and then this line will have the same length with the exact object or line AB at the previous one. So it will have this length, and then its top view can be constructed in this way. So AT/BT will be the projections of the line on the horizontal plane. That means it is just a top view. So if you are asked to construct the top views of a given line, so you can construct in this way. So in this portion, once you see over here, the two lines, that means the front view and the side views are foreshortened. That means the lengths are diminished rather than the actual lengths, but from the top view, we can get the true lengths. So if the line is parallel to one plane, so it will have a true length on that plane, but it will have a diminished length on the other plane. This is just for the cases of an inclined plane. The same procedure can be happen if the line is just parallel to the profile plane. Let me show you the projections of this line. So if the line AB is just parallel to the profile plane, that means it will have a two lengths on that profile plane, and then it will have a foreshortened lengths on the vertical and on the horizontal plane. So let's just construct that one. If you construct the front views of this line, it will have such types of vertical line. So point A and point B can be projected in this way. So the layout or the projections of this line can be AF and BF. So the projections of that line on the front view or on the vertical plane will be this one. So we'll have a diminished or a foreshortened line here. And then the other thing, if you just construct into the top view, the same thing will be happen. That means the line will have shortened and then it will be AT and BT. So the line will be constructed in this way, but the line is also vertical line here. So you can construct AT, BT from the multi-view drawing. What will be the projections of this line on the profile plane? On the profile plane or on the side view, that means when we are looking from the side view, it will have a true length. So AR, BR will be the true lengths of the given line. And then it can be constructed just like this one. So you can get this line. So in this case, this is a true length, but the other two lines will be foreshortened. For the projections of inclined lines, you have to remember that it will have one true length on one plane. It will be on the vertical plane, it will be on the horizontal plane, or it will be on the profile plane. That means it will be on the front view, on the top view, or the side view. But it will have only one true length, and then it will have two foreshortened lines here. In this video, I will show you one example related to the projections of inclined line. For example, if the question is given in this way, that means locate the given line in a standard coordinate system and then sketch their front, top, and side projection using first angle projection system. So the question will be that, and then the line AB is just given with the coordinate points of A, line AB, where A is 337 and B is 657. Means X, Y, and Z coordinate systems are given, and then use 1 unit equals to 1 centimeter. That means the unit is given in centimeter. So how we could just construct the multi-view drawings of this object can be shown here. So I will show you this starting from the locations of this line on the 3D. Now to locate that, point out or locate point A and point B. If you just get point A and point B, you can just connect them with a line, so that line will be line AB. So where are the positions of point A? The positions of point A is X in 3 centimeters. So in the X 3 centimeters, so we'll measure from this origin into the x-axis with 3 centimeters in this way. So once you get that, in the y it's 3 centimeters too. So in the y it will be 3 centimeters. That means in the vertical direction it will have 3 centimeter length. Once you measure that, in the z direction it is just 7 centimeters here. So parallel to the z-axis will measure 7 centimeters from here to here. So that one will be the positions of that point A. And then the other thing, for the positions of point B, it is 6 centimeters in the X. So from here to here, we'll measure 6 centimeters. And then it is 5 centimeters in the Y direction. So it will be Y 5 centimeters. And then it will be 7 centimeters in the Z direction. So it will be constructed here. Once we get that, we can connect points A and B. Then finally, we'll have a line AB just like this. So this is how we could just locate the line on the axis system X, Y, Z. Once we do this, how we could just project the front view, top view, and side views of this line. For the front view, we'll use just X and Y because it is a vertical plane, and then the front view will be on the vertical plane. And then the combinations of X and Y of the point will be helpful for constructing that line. Now, let's just project point A. So point A in the X and Y is, in the X it is 3, and then in the Y it is 3, 2. So that means from here to here we'll measure 3 centimeters, and then from here to here in the Y we'll measure 3 centimeters. That means the coordinate point X, Y, 3, 3 will be the locations of point A. And then the locations of point B will be, in the X it is just 6, and then in the Y it's 5. That means in the X from here to here it will be 6, and then in the Y it will be 5, just like this one. So if you just point out the two locations, then we can connect that. Then finally, once you connect that length, you'll get the projections of the given line. As you see here, it's inclined line. So since it is inclined line here, or since it is on parallel to the vertical plane, that means it is with a true length. And then the other one, the top view will be constructed with the help of X and Z. That means the coordinate point of A in the x is 3 and then in the z is 7. That means 3 is normal, it's aligned on this vertical line. And then 7 means if you measure from here to here with 7 centimeter, you will get the exact locations of point A on the top view. So that is 8t. And then the same thing for point B. On the x-axis it is 6 and then in the z-axis it is just 7. So once you measure from here to it will be 7 and then finally you will get point B. So AT and BT will be the top views of the line AB here, and then you can connect them, you'll get that line. So the projection or the top views of the line is just constructed in this way. So in this case, it's just a horizontal line. The same thing can be happen for a side view. That means for right side view, we can use Y and Z coordinate system. So the Y of point A is 3, and then the Z of point A is 7. That means Y is just from here to here, and then the Z is 7. So from here to here, if you measure that, it will be 7. So finally, you will get the locations of point A on the side view. Once you do this, you can get the same way for a point B. That means in the Y, it is 5 from here to it will be 5. Normally, it is on the horizontal plane that's previously constructed. And then in the Z, it will be the same as A, and then it will be 7 here. So if you connect AR and BR in this line, so finally, you will get the projection or the multi-view drawings of the line on the profile plane, that is a side view. So for this question, we can construct the two drawing just to give enough information related to the intended question here. So this is just how we could project an inclined line. As you observe here, this line, that means the line on the vertical plane or on the front view, is with a true length, but the other two lines, that means the side view and the top views, are foreshortened. So this is just the nature of the inclined plane. If you are interested to know more about projections of lines or points, you can just visit our YouTube channel. Thank you for watching, and then see you soon.